Today we're going to do this AOPS problem from Introduction to Algebra, and it's problem 20.32. So it says graph the equation y equals the absolute value of x plus 3 minus the absolute value of x plus 9. So the reason I chose this problem to talk about is because I got this problem wrong just now when I was doing AOPS. So let's start by casework. So case 1 is we have both x plus 3 and x plus 9 to be larger than 0. To be larger or equal to 0. So this means that x is larger or equal to negative 3 and x is larger or equal to negative 9. Well, having x larger or equal to negative 3 is an inequality with a smaller set of numbers. So this is our inequality for case 1. And since x plus 3 is larger or equal to 0 and x plus 9 is larger than or equal to 0, our equation becomes y equals x plus 3 minus x plus 9. That's x plus 3 minus x minus 9, which is negative 6. So we get the line y equals negative 6. For case 2, let x plus 3 be larger or equal to 0, but x plus 9 is less than 0. So this means that x is larger or equal to negative 3 and x is less than negative 9. So clearly this is impossible. So if we draw this on a number line, this is negative 9 and this is negative 3. X is larger than negative 3 indicates that this part is x. X is less than negative 9 indicates that this part is x. These two regions don't even intersect, so this possibility is impossible. So now let's move on to case 3, where so case 3 is where x plus 3 is less than 0 and x plus 9 is larger or equal to 0. So in this case, x is less than or equal to negative 3 and x is larger than or equal to negative 9. So this works. So we've got the inequality x is greater or equal to negative 9 and it's less than negative 3. So in this case, we can simplify the equation of the function as y equals negative x plus 3 minus x plus 9. This gives us negative x minus 3 minus x minus 9. So we get negative 2x minus 12. Now we have one last case to consider, which is case 4. Wait, what's this? So one last case, we consider case 4. So x plus 3 is less than 0, and x plus 9 is also less than 0. In this case, x is less than negative 3, and x is less than negative 9. So x is less than negative 9 is a stricter inequality, so we choose x is less than negative 9 as the inequality for case 4. So in this case, we can simplify the equation as y equals minus x plus 3 minus x plus 9. So we have minus x minus 3 plus x plus 9. So the two x's cancel out and we get y equals 6. So let's just check through our working first. So you can also read through this part and see if there's any errors. So I'm going to check. So I don't think there's any errors, so we can graph the equation right now. So we can draw the coordinate plane. So this is the coordinate plane, and we start from having x being less than negative 9. So when x is less than negative 9, we have the line y equals 6. So let's find negative 9 on the x-axis, and we find negative 6 on the y-axis. So let's assume that's the 2 points. and we can graph the equation. So we'd have a line like this, and there's an arrow here indicating that continues on forever. And then case two is, so the second part of our graph would be made up of case 3, when -9 is less than or equal to x less than -3. So firstly we find the boundaries of x. So where's -3? That's 1/3 of the way from the origin, so that's approximately -3. Then we figure out what equation we have. So we have -2x minus 12. So what happens to that equation when x is 9? No, when x is -9. When x is -9, y equals -2 times -9 minus 12. So that's 18 minus 12, which is 6. So essentially, it's this line continued. So we plot this point here. And then let's say we allow x to equal -3. I know that's not true because x is less than -3, but let's just assume x is equal to -3 and see what happens. So when x is equal to -3, we have y equals 6 minus 12, which is -6. And we find -6 on the y-axis. So let's say this is -6, and we plot this point over here. But I know that's not true, and this point doesn't count as part of the graph, so I put an empty circle. I put an empty circle for this point because it's not included part of the graph. So now I have 2 points and I have a confirmed line, so I can connect these 2 lines. So this is our graph, and then section 3 of our graph is when x is larger or equal to -3. So in this case, we have y equals -6. So this is our line over here. So we can draw that. And we can have an arrow to indicate that it goes on forever. And in fact, this point can be an actual dot because -6 is the value of x when x is equal to -3 is -6. So this is our graph, and the tricky part is the casework. You have to be really careful of the calculation, etc. So if it were me, if I were the judge, then I would create questions something like this, and potentially I would even add more cases, like let's say plus x plus 6, and then minus x minus 4. So if I had so much cases, hoping the contestants will be confused. So when you face this type of question, be particularly careful and order your casework, and also remember to use a number line if you're really confused, like this one. If you're not sure or you're confused because the problem takes a long time to solve. So I hope you learn something from this problem. This is AOPS Introduction to Algebra, problem 20.32, and it's about absolute values and graphing them. So beware to do casework, and bye. Remember to like, subscribe, and share.